Hello everyone, welcome back to the series. In this series, we will talk about different ways to optimize our delta tables. Okay, optimization on delta tables. Now, there are different technologies, right, which we use, and each technology provides their own features to optimize these delta tables. Like when we are working with the Databricks, right, we are internally generally use Spark, right? Similarly, we use Delta Lake or Data Lake, whatever, or Delta Table, right? Delta Lake, or you use basically a platform called Databricks, right? Because you are working with the Databricks. Now, since we are using three different technologies, right, each one has their own features which will help you to actually optimize your delta tables. The first one is Spark. So Spark offers couple of methods to optimize your delta table, like partitioning, like bucketing, right, like cache, right, like persist, right, and similarly there are so many methods. Just like Spark, delta table also offers couple of methods which helps us to improve our performance, like z order, okay, like vacuum, like optimize method itself, okay, like checkpoints. And we will talk about each of them, like where exactly they are optimizing your delta table, or what all features they are providing to uh, make your table optimize, right, or to get the better performance, basically you can think of. Similarly, Databricks also provide couple of features or the benefits or the function or the tools, right, which will help you to improve your performance in terms of reading and writing, right? Like Databricks has photon engine, right, or they have some cluster configuration which you can leverage, or they have a concept of unity catalog, right, or you can use what we call delta cache, right, and autoloader, right. So there are multiple features or functions given by these three different technologies, and each one provides their own optimization methods, right? So you should be knowing like where exactly what all optimizations you can use. So let's suppose if you are working in a Synapse, right? So you cannot use these all methods, right? Because they are given by the Databricks platform itself, right? But you are good to go with this and these methods, right? So that is why we should understand how these optimization methods are created and by which technology they will be offered to us, right? Now, to understand how we can leverage and what all benefits they provide, right, first of all we need to understand how delta table actually stores the data, okay, or what all things it actually stores when we try to write something in the form of delta lakes or delta tables, okay. So let's talk about those two main components, right, which generally gets created with delta table. So delta table, right, whenever we try to write the delta table, right, we are actually uh, creating two important concepts here, or we are actually getting two important things out of it. This, the first thing is your underlying data itself, or you can think of data storage, right? Data storage in you can think of, or you can check, right? It will always store in the form of Parquet, right? But still it is different. We call it delta table because it's not just only create these Parquet formats files, right, but it also create transaction logs. Okay, these transaction logs are basically the metadata. Okay, these transaction logs are basically the metadata, and when I say metadata, it includes everything like the schema information, okay, like changes in the data, right, like the properties of data, size of data, and other informations related to data, uh, at what time they read, right, what was the last data we read in the delta table, what all different versions are in this particular delta table, right? So all this information will be stored in these transactional logs, right? So now when we create the delta table, we will have the actual files in the form of delta table in the form of Parquet, and we have this transaction logs where we have entire metadata stored. These are the two crucial components present in the delta table. Okay, now if you perform any kind of operation in this delta table or in this delta table, right, whether it is insert operation, or you are doing upsert operation, or you are doing append, or you are doing delete, or you are doing whatever operation, right, the logs will be always be stored in transactional log. Okay, all the logs will be stored in transactional log, and if it is a new data or change in the data or whatever, right, a new Parquet file will be created in this particular folder. Okay, got it? So in this way, the delta table is able to store the data as well as store the information related to the data. So if you perform any kind of optimizations, right, it underline change these two things. First, the way the data is stored, and the second, the information which metadata holds. These two things will be changed. Okay, and when we start doing these operations one by one, right, I will show you how exactly they got changed. Okay, and where exactly you can check these changes. Okay, so this is the basics of optimization, and these are a few of the methods, and this is how basically we will be covering this particular series. Okay, one more or last thing is, these optimizations are not just for reading the data, but they are also sometime important while writing the data itself, right? So suppose we are reading the data from the CSV and we wanted to write the data into the delta table, and it is taking time, right? So few of the methods you will use to optimize your writing process as well, right? So we will talk about it, right? How we will do, which all methods will be used while reading the data or while writing the data or while querying the data, right? We will talk about it. So I hope this makes sense, right? If you have any questions, just let me know. And in the next video, we will start going through each of them one by one, and we'll cover this. I hope you will be, I mean, like this video will be helpful for you guys. Thank you. Thanks for watching the video. Bye.